Okay, so for the first one here, it's really a rather simple form of the equation. It's just complex because of the fractions that are in it. But that equation is identical to having something like 5x minus 7 equals 48. So the process of solving that equation is exactly the same as the process of solving this one. Over here, we would add the 7, and then we would divide. Over here, what are we going to do? What's our first step to solve that? Okay, add the 2 and an eighth. So that's gone. We've got the 3/4 x here. Equals 5 and 5/8. So from there, 3/4 x equals 5 and 5/8. What do we have to do next? We have to get rid of that 3/4. So we're going to divide by 3/4. So we've got x equals 5 and 5/8 divided by 3/4. So I'm going to change this into improper fractions. 5 and 5/8, 5 times 8 is 40, plus 5 is 45/8. And instead of divided by 3/4, we're going to go times 4/3. We'll cross cancel the 8 and 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And we can cross cancel the 45 and 3. 3 divided by 3 is 1. 45 divided by 3 is 15. So 15 times 1 is 15. 2 times 1 is 2. So 15 over 2 is 7 1/2. So that equation comes out to be 7 1/2. Now I realize you're looking at these equations thinking they might be look more complex than what you'd ever use, but they're really not. Each of the equations I've chosen here has applications that I've used them for. For example, this next one down here, maybe not in this exact form. In fact, I simplified the numbers. Most of the time it would be decimals. This is the exact form of an equation I would use for mixing different solutions. If I had two solutions of different concentrations that I needed to mix to get a specified concentration, this is the type of equation I would use. So let's go through and solve this one, and then I'll come back and I'll show you what I mean by this type of equation. So let's, we see the parentheses. We'll start on the left side. So we start with the first parentheses on the far left. There's nothing to do inside that parentheses, so we're going to multiply by the 5. 5 times 3x is 15x. 5 times negative 7 is negative 35. Now this second set of parentheses is where I would catch most people messing up, because there's nothing to do inside that parentheses, and it looks like there's nothing being done to them, but we've got the negative up here, the minus. So we treat that as a negative 1, and we distribute it, multiply that through the parentheses. So negative 1 times 2x is negative 2x. And negative 1 times negative 4 is a positive 4. So let's keep combining things on the left side. What can we combine over here on the left right now?
15x and negative 2x.
15x and negative 2x. Good. And that creates what?
13x.
13x. Good. And then we have the negative 35, which would combine with
Positive 4, which is going to make it 31, right?
negative 31. Yes. Perfect. So on the right side, we still have 3x plus 39. What's next? Remember, we can't start to actually solve it until we have it simplified to the point where the variable appears only once. And right now, the variable appears twice. There you go. We get rid of one of them because they're on each side. So we subtract 3x, that is gone. 13x minus 3x is 10x minus 31 equals 39. And now it's in a form where we can start to solve. Yep, add 31. So 10x equals 70. And then? Divide by 10.
X equals 7.
X equals 7. Perfect. Okay, so where would I use this? Well, if we're looking at mixing solutions, I'm trying to think on the construction site where I've needed to do it. I've needed to do it several times on the machining side of things. Well, let's just go with a generic solution. And when we're looking at solutions and solution concentration, the amount of the active ingredient in a solution. Now, a solution is made up of two parts. There's a solvent, and the solvent is usually a liquid, and it is usually inactive. So the solvent, like, think a simple solution might be a salt water solution. So in a simple salt water solution, the solvent would be the water, and it has no activity to it. There's no significance to it. Then there's the solute, and the solute is usually the active ingredient. So some places where we would use a solution, for a lot of your stuff, if you have to do any concrete work or anything like that, you have a lot of tools, your power trowels and stuff like that. Many of those are two-cycle motors where you have to mix gas. I also do for cement forms, you have to use a lot of times it's a kerosene or an oil and whatever solvent you're going to use mixture in order to do a release on the form so that they'll release from the concrete when you're done. So mixing those solutions, having the right mixture, especially if you're looking at a two-cycle motor, is very important. So the amount of that active ingredient that is in a solution, I get my pen to work here, the amount of the solute that's in the solution, that's that active ingredient, is equal to the concentration times the total volume. So let's say we have a solution that is 35% oil in paint thinner that you're using as a release agent on a form. So what that means is the amount of oil, the 35% oil is indicating the oil is the solute. That is our active ingredient. So the amount of oil that is in that mixture, 35% is going to be written as a rate, 0.35. And let's say we have a total solution here of 300 milliliters. So it's going to be 0.35 times our 300 milliliters of total solution. So 0.35 times 300 milliliters is 105 milliliters. So the amount of oil that's in that mixture is 105 milliliters. So let's say we're looking at an oil and gas mixture. Now I realize most of your oil and gas mixtures are given as a 50-to-1 or 20-to-1 or 15-to-1 or whatever. But we can convert those into percents and use them in percents. Let's say we have a mixture that is already a 15-to-1 mixture, and we have another mixture that is a 50-to-1 mixture of gas and oil. We need a 25-to-1 mixture. Well, we need to convert these into percents to make this work out. 15-to-1, 1 divided by 15 is a decimal, is going to give us 0.0666. That is going to be 6.67%. 50-to-1, 1 out of 50 is 0.02, so that's going to be a 2% mixture. And 25-to-1, 1 out of 25, is going to be 0.04 or a 4% mixture. So we need to know now to mix these, how do we end up with that 4% mixture? Well, I'm going to go and I'm going to do some blind mixing here first just to show you how this works. So let's say we are going to blind mix. We're going to mix 200 milliliters. Now you could use fluid ounces, you could use whatever measuring unit you're using. I'm using milliliters just because it's handy to use. 200 milliliters of the 6.67%, that's the 15 to 1, with 300 milliliters of the 2%. Let's see what we end up with. So the equation for mixing those is going to look like this. The 6.67% is going to be 0.0667 times the volume of that is 200 milliliters. And what we are adding to that is the 300 milliliters of the 2%. So 2% is 0.02 times 300 milliliters is the amount of oil in that one. And we need to find what that concentration would be if we mix it. So X is going to be our percent here. The total volume is going to be 200 plus 300, or 500 milliliters. So now let's see what we end up getting for that concentration in our final mixture. So we've got 0.667 or 0.0667 times 200, which should give us 13.333, 13 1/3, plus 0.02 times 300, which is 6. X times 500 is going to be 500x. So now we've got to combine here. 13 1/3 plus 6 is 19 1/3 equals 500x. And we divide it out, solve for x. So dividing out the 500, so 13 1/3, I'm going to add my 6 to that and get 19 1/3. I'll divide out my 500. So 0.03867. So if we move the decimal point to make that back into a percent, that is a 3.867%. Well, we needed 4%, so that's not quite going to work. It's a little bit diluted. So let's look at it from a more exact direction. Rather than just blindly mixing two amounts, I mixed a little bit more of the 2% because the 4% is, 4 is closer to 2 than it is to 6.67. Let's actually put in amounts here and calculate how much we have to add. So let's say we're looking at, we have 360 milliliters of that 2%, that 50 to 1. Remember, that's the 50 to 1. How much of that 15 to 1, the 6.67%, do we need to mix with that to create that desired 4%, or that 25 to 1? So what we have here is we have our 2% that we were mixing with our 6.67%, trying to create that 4% mixture. We have amounts. The only amount we're given is the 360 milliliters of the 2%. So the amount of the 6.67% is going to be our X. So the total amount, if I scroll up for a second, just like up here, it was 200 plus 300 gave us 500. Same thing's going to happen here. 360 plus X is going to be 360 plus X. So then the equation we create here, 2% times 360, so that's going to be 0.02 times 360, plus my 6.67 is going to be 0.0667 times X, has to equal my 4% is 0.04 times 360 plus X. So my 0.02 times 360 is 7.2. 0.0667 times X is 0.0667X equals .04 times 360 is 14.4. And 0.04 times x is 0.04x. So now, just like we were looking at before on those equations, we had to multiply through the parentheses to get this. And now we have a variable on each side. We have to get rid of one. We'll get rid of the 0.04x. So what we have left over here is 14.4. On the left side, 0.0667 minus 0.04x is 0.0267x. We still have the 7.2. So now we're going to solve. We're down to one appearance of the variable, so we can solve the equation. So what are we going to do next? So here's our x. We got to get rid of everything else. What's the first thing we're going to do to solve that? Perfect. We're going to subtract the 7.2. So that's gone. We have 0.0267x equals 14.4 minus 7.2 is 7.2. Now we're going to divide here by the 0.0267. We are going to get an ugly decimal here, but that is okay. So 269.66, basically 270 milliliters is what I would mix in. Now this is just one example kind of on the fly here. If I sat down and thought about it, I could come up with more examples of these mixtures where you would have to do mixtures like this. There are a lot of other examples that we'll look at that we're not quite ready yet. At some point, we'll look at solving equations for dual slope trusses. Now let's do one. Let's see how we do it. So let's say that this side of the truss has a 16 and 12 slope, and this side over here has a 4 and 12 slope. And we know that this side here is, well, let's give it a 40-foot span. I want to know where the peak of this is located. So I'm going to call this x here. I also would like to know the height of that truss. Now this dimension right here, I'm not going to define it with a variable, but I'm going to define it as the span of 40 minus x. Whatever this length ends up to being, I subtract that from the whole span to get what's left over on the right side there. So looking at this equation, we have those two lengths together. On the right side here, there's a relationship with h and x. We know that there's a 16 and 12 slope. And that's going to equal our height, our rise over our run, h over x. So we can cross multiply here. 16 times x is 16x. H times 12 is 12h. We know that 12h is equal to 16x. Now we can look at the other side over here, this side, with the 412 slope. We know that 412 slope still has a height of h, but now the run is 40 minus x. So if we cross multiply in this one, we've got h times 12 is 12h. Over here we've got 4 times 40 minus x. And I'm just going to write it as 4 times 40 minus x. So looking at this, we have two equations, but both equations have 12h equals something else in them. So what that means is if 16x is equal to 12h and 4 times 40 minus x is equal to 12h, then they must be equal to each other. 16x must be equal to 4 times 40 minus x. So now if that's the case, I can now solve for x. What would I have to do first in solving this equation?
4 times 40 and 20.
Perfect.
X.
Perfect. I have the parentheses here, so I've got to focus there first. There's nothing to do inside them, so I'm going to multiply by the 4. So 4 times 40 is 160. Perfect. 4 times negative x?
Negative 40. Negative 4x.
Negative 4x. Good. So now we've got 16x on this side. We still have to get rid of one of the x's before we can start to solve. So which one are we going to get rid of?
Negative 4x.
Negative 4x. We get rid of it by
Adding
adding 4x. Perfect. So 16x plus 4x is 20x equals 160. And our final step in solving this? Divide by 20. Good. So x equals 8. So what that is telling us is on this truss, the peak here is 8 feet from the left end, and 40 minus 8, or 32 feet from the right end. We could also find the height, by the way, if we wanted to from that. We could use either of these equations. I would use this one here that's a little bit simpler. 12h equals 16x. Well, once we know that x equals 8, we can replace this x with 8. So 16x becomes 16 times 8. So here the 12h is not going to change quite yet. But 16 times 8 is 128. So then we divide by 12 to get h. If we divide by 12, h is equal to 10 and 2/3. Now 10 and 2/3 feet. At this point, have you guys started to see the pattern with 2/3 feet is how many inches? So 10 and 2/3 feet is 10 feet, 8 inches. Let's take a look at that. Some common fractions, if you guys are going to be working in construction, some common fractional feet, I'm kind of going off on a little bit of a tangent here, but some common fractional feet that you should be starting to see is 1/4 of a foot is 1/4 times 12, or 3 inches. That's going to come up often enough that you should be able to see that and just know that one off the top of your head. 1/3 of a foot is 1/3 times 12, or 4 inches. One half of a foot? Well, you can tell me, anybody tell me how many inches are in half a foot? 6 inches, good. Next would be 2/3 of a foot. 2/3 of a foot is 2/3 times 12. That's the 8 inches that we just saw up here. And then 3/4 of a foot. 9 inches, very good. 3/4 times 12 is 9 inches. Those 5 relationships, those 5 fractions of a foot, I should say of a feet. Those 5 fractions of a foot, you should have memorized very shortly if you're going to be working in the construction industry. There are some beyond that. If you were to be working in there for a long time, I would expect you to memorize that 1/8 of a foot is 1.5 inches, and 3/8 of a foot is 4.5 inches, and so on. But at this point, these are the 5 big ones that I think you should be should have these down soon. Okay. So let's do one more example of these equations here. So let's do another dual slope truss. Let's say this is an 1812 slope on this side. Let's go with a 312 slope on this side. And a 42-foot span. And I want to find, I'm going to call this X here. This is my height. So then this here is going to be, again, 42 minus X. Whatever the length is minus the other piece has to be what's left over. Now the key here is, whenever you're looking at any truss, we went over this briefly when we looked at similar triangles and ratio and proportion. Anytime you have a truss, if you want to find the height of that truss, so we're going to label that H for height, you need to know the slope. So let's say this is a 412 slope. And you need to know the span. So let's say this is a 36-foot span. Technically, what I need off of that span is not the span, but the run. That slope goes off of a rise and a run. So the run here is going to be half of the span, half the 36, 18 feet. It's the distance from one end of the truss to the peak. So the slope here, this symbol means that is a 4 and 12 slope. It's a 412 slope. Is going to be equal to my rise, which in this case is the height of H, so I'm just going to put in H, over my run, which is 18. And just like when we did percent, you can cross multiply and divide. And in this one, you would just cross multiply and divide because there's only one unknown. If there's two unknowns, remember you cross multiply in both directions, and those two amounts have to be equal to each other. Well, here there's only one missing number. That's just the H, so we're just going to cross multiply and divide. 4 times 18 is 72. Divided by 12 gives us that H is 6. So this truss is 6 feet tall. So let's say we're looking at this. We want to build a building with this type of slope on our roof. It's a 42-foot span, and we want that 1812 on one side and 312 on the other. But we know there are shipping requirements that 13 foot 8 inches is the tallest that we can ship. And actually, a lot of companies will say 12 foot 6 is the tallest you can ship because of the way their trucks are set up. Let's say we're going to go 13 foot 8. So looking at this, we're going to do the same thing. We're going to look at the left side of this truss first, which is this triangle here. Which slope is describing that side of the triangle? That side of our truss? The 312, very good. So that is a 312 slope. So in the green triangle here, what is the rise of, what describes the rise of that triangle, or the height?
H.
H does, very good. And the run is described by X. So again, here we cannot just cross multiply and divide because we have two variables, two unknowns. So we're going to cross multiply in each direction and set them equal to each other. So I've got 3 times X is 3X. And so H times 12 is 12H. So 12H equals 3X. So I'm going to leave that for now. On the other side over here, on this triangle, what slope describes that side of the truss?
H and 40. No.
Well, the slope would be, you've got the right idea, but the slope that describes it is the 18, right?
Yeah.
So then what describes the rise of that is, what you were saying is
H.
H.
The 42 minus X.
Perfect. And the run is the 42 minus X. Very good. So now we're going to cross multiply here. H times 12 is 12H again. That has to equal 18 times 42 minus X is 18 times 42 minus X. So again, we end up with an equation. Since both of these equal 12H, I can just set them equal to each other. I'll do the 18 times 42 minus X has to equal the 3X. So now to solve this, our first step is going to be the parentheses. Is there anything we can do inside those parentheses?
18 times 42.
Okay. Yeah, we can't combine anything in them, so we have to multiply by the 18. You are correct. 18 times 42 is what?
756.
756. Good. Then we have to do the 18 times the negative X.
This is negative 18X.
Negative 18X. Let's have a seat, gentlemen. Thank you. Then we've got the 3X on the other side there yet. So what do we still need to do? We need to get, before we can solve, we still need to have to do what?
To get rid of the smaller X.
Get rid of the smaller X. Now this one can be deceiving. What's the smaller one here?
Negative 18.
Negative 18. Good. And we'll get rid of it by
Adding 18X.
adding 18X. Wonderful. So that's gone. We got 756 here. 3X plus 18X is 21X. And now we solve this by dividing by 21. Good. So that 21 is gone. We've got X here. 756 divided by 21 is
36.
36. Good. So X is 36. So going up here, that tells us that X here is 36 feet. This is 42 minus 36, or 6 feet. Well, now we need to figure out what H is, because remember we said we're trying to keep that shipping height, making sure our shipping height is under 13.8. So we've got this equation here, 12H equals 3X. And we know now that X is 36. So 12H equals 3 times 36. We replace X with 36. 3 times 36 is 108. And our last step is divide by 12. Good. So H equals 9. So that's telling us is the height of this is 9 feet. So we are well under a 13-foot, 8-inch limit. Any questions? Okay. Well, there's one similar to those that we can look at. We can look at a porch truss. We've all seen houses where you've got the steeper roof on the main roof, and then at some point they've put 2x6s or 2x8s up into that roof to build a porch off the side. They actually build a truss that does that all for you. Oops. So here we've got a truss. We got 10-12 slope up on the main part of the roof, and then the porch that protrudes off the side of it is a 5-12 slope. So let's say that this is, let's go 16 feet here. Oh, let's go 40 foot total. What I want to know is I want to know how far it is from here out to the end of this truss. So I'll call that X. we're going to deal with h here in the process of this. Only this time we can actually calculate h. If I look at this here, the slope that describes that side of the truss, that triangle, is the 1012. The height of that triangle is described by what? The rise is the h, good. And the run is perfect, 16. So we can cross multiply and divide. 10 times 16 is 160. Divided by 12 is, what does that give us? 13. 13 and a third. Perfect. So that's 13 and 1/3 feet. So of course that's 13 feet and how many inches? 1/3 foot is how many inches? That'd be 4 inches, right? Perfect. So 13 foot 4 inches. So now in this one, we're looking at this dimension here. It's not going to be 40 minus x because we've got 16 feet on this end. So what would this distance here be in the red? The whole thing is 40. There we go. I heard somebody say it. 24 feet. So that's 24 feet. Which makes this piece here 24 minus x. So the problem here is these two, what we have here is not two pieces that come up to the same height. These are two pieces that add up to a known height. You've got this piece here and this piece here that have to add up to that total height of 13 1/3 feet, or 13 feet 4 inches. So let's look at how we describe this height right here. We have, that's a 512 slope there. And I'm just going to put a letter in here to hold its place. I'm going to call that A. That's going to be A over X. So I'm going to cross multiply. 5 times X is 5X. A times 12 is 12A. That equals 5X. To find out what, I'm going to solve this for A by dividing by 12. So A equals 5/12 So this is 5/12 x, is that height. So in this one up here, I'm going to call that B just to start out for a calculation here. That's a 10/12 slope. So in that triangle, we've got the 10/12 slope. The rise of that was B, and the run was the 24 minus x. So we cross multiply there. We've got B times 12 is 12B equals 10 times 24 minus x. So the 12B here, 10 times 24 minus x, 10 times 24 is 240. 10 times negative x is a negative 10x. Now I'm going to divide by 12. When I divide, I have to divide every piece by 12. So that's gone. B equals 240 divided by 12 is 20. Negative 10x divided by 12 is negative 10 over 12, or negative 5/6 x. So what I've done there is found this piece here to be 20 minus 5/6 x. And I know that these two pieces have to add up to my total height of 13'4". So that's 13 1/3 feet. Has to equal my 5/12 x here, plus, here I have 20 minus 5/6x. It's going to be interesting. So let's see if this works out for us when I solve it. So we're going to combine the 5/12 and negative 5/6, which makes a negative 5/12. Now we have the variable, oops, that's x, of course. Now we have the variable there just once, so we'll subtract 20. Gives us 6 2/3, negative 6 2/3 equals a negative 5/12x. So negative 6 2/3 divided by a negative 5/12. I'm going to do this on the calculator for you to speed along because I know you guys want to get to your break. So 6 2/3 divided by 5/12. We get 16. So x here is 16 feet. So up here that's saying that this piece is 16 feet. Okay, it's that time, so I'll let you guys take your break. Let's come back about 2:50. Yeah. Come back at 2:50. Okay, so hopefully with what I just showed you, you can see how these equations, as complex as they might look, actually do have applications. You will actually see equations like that in the construction field. Now, the next step we want to do is we want to look at using these formulas and equations. If we're going to be using them over and over again for multiple things, of rearranging them. For example, we had that relationship up top where we had 12h equals 3x. And we found several different, for this case, there's one value of x. And we found that if x is equal to 16, then we could find that height. So we put 16 in for x. So 12h instead of being 3x is 3 times 16. We combined what we could. 3 times 16 is 48. So 12h equals 48. And then we solve by dividing by 12. So h equals 4. Which this process is fine if we're going to do this once. But if I'm going to be doing this over and over again, if I have multiple values of x that I'm going to be putting in there and trying to figure out what I need for a value of h, it would be more efficient to rearrange this formula so that it was of the form h equals and have everything else on the other side. So I can just plug in the values for the other variables and do order of operations. So let's look at how we would go about doing that. So 12h equals 3x. We actually did a couple of examples of this up above. But if I wanted to get h alone, I want to solve this for h. Well, that means I have to get h all by itself. So here's the equal sign right here. This is where the h is. So we ask, what's keeping h from being by itself? That's going to be the 12. And what operation is tying the 12 to the h right now? Well, the 12 is multiplying the h. So to get rid of it, the opposite of multiplying is dividing. Thank you. So we're going to divide by 12. That gets rid of that 12. Leaves it with h. But now we have 3x divided by 12. Well, 3x divided by 12, we're going to treat it as 3 over 12x, which reduces to 1/4 x. So h is just equal to 1/4 times x. So let's look at some other formulas where that might be applicable. We had 12a up above equals 240 minus the 10x. So again here, if we wanted to solve this for A, again, we find our equal sign, and then we identify where A is. There's our A. So we have to get A by itself. Once again, A is being multiplied by 12. So to get rid of that, we would divide by 12. So dividing by 12 over here gets rid of the 12. When we multiply or divide in an equation, we have to do it to every digit. Now, I didn't say every piece or every item because the 12A here is a single digit. So I don't divide the 12 and divide the A. I just divide that single digit. So dividing 12A by 12 just cancels out the 12. On the other side here, we have two digits. We have the 240 and we have the negative 10x. So I divide this over here by 12. Each digit has to be divided. So 240 divided by 12, we said was 20. And then we have negative 10x divided by 12. Negative 10x divided by 12 is simply negative 10 over 12x. And of course, that can be simplified. Negative 10 over 12 is a negative 5 over 6x. So we've solved that for A. It's now in the form of A equals. And so if we have different values of x that come in, we can solve for A rather quickly. So if I find out that x equals 18, well then A is equal to 20 minus 5/6 times 18. And now it's just an order of operations problem to solve that. First thing we have to do is the multiplication. 5/6 times 18 is 15. And then it's just 20 minus 15 is 5. So A equals 5. So let's look at some other formulas and rearranging them. We might have something like this. Px minus c equals d. You might recognize this. It looks a lot like equations we've solved before with numbers in them. It might have been like 5x minus, well, use the example used before. 5x minus 7 equals 38. We solved that equation by adding 7 and dividing by 5. Well, over here, we're going to follow that same process. If we're going to solve this for x, we do have to specify that x is the variable we want to solve for. Just like over here, we would add 7 first. Over here, we're going to add not 7, but c. Now, when we add or subtract in an equation, when we add or subtract, we only have to do it to one piece on each side. One digit on each side. So we add the c here, that makes that go away. All I have to do is add c somewhere on the other side of the equation. So that means the px doesn't get affected. On the other side, d plus c, well, that just has to stay d plus c. There's nothing I can do to combine those any further. And now, I have to divide by p to get x by itself. So that leaves me with x. Remember, when I divide, I have to divide every digit. So over here, I've got d plus c all divided by p. Well, that could be d divided by p and c divided by p. But since neither one of those can be divided out, I can just leave it like this as d plus c over p. Or I could split it up as x is equal to d divided by p plus c divided by p. I would leave it like this just because that's less steps. Once I know d, c, and p, it's less steps then to find x. Let me show you. In the next step, let's say that we are told that D equals 18, C equals 12, and P equals 6. So now in this equation here, all I have to do is replace D with 18, C is replaced with 12, and replace the P with 6. And so to find x, order of operations, the fraction bar tells me I have to do everything on top first. So 18 plus 12 is 30, divided by 6 is 5. So x in this case would be 5. This would give me the same thing if I had it in that form. It's just I would have D is 18 over P, which is 6. C is 12 over P, which is 6. It's just a little bit more, one more step really. 18 divided by 6 is 3. 12 divided by 6 is 2. And 3 plus 2 does give us 5. So it'll work out either way. Or you might be given D equals 15, C equals 35, and P equals 5. So now you have to go back and resolve that. X equals D plus C over P. Well, D is 15 plus C is 35 over P is 5. So now you can see 15 plus 35 is 50. 50 divided by 5 is 10, so x would be 10 in that case. So looking at that, once we have it solved in the form of x is equal to D plus C over P, it's relatively easy to plug in those numbers and get the result for x. Let's go back to the original form of this, Px minus C equals D, and see how much work that would be. So Px minus C equals D. The first numbers we had up here, remember we said D is 18, C is 12, and P is 6. So to put those in, P is 6, so this becomes 6 times x, minus C is 12, equals D is 18. So to solve for x, we got to solve the equation. We would add 12. 6x equals 30. And then what? It's 6 times x, so to get x by itself, I would divide by 6. So x equals 5, which is the same answer I got before, but this was just more work. Then if we look at the second set of conditions I gave you, D is 15, C is 35, and P is 5. We would have to go through that same process again. So we're still plugging them in here. P is 5, so Px becomes 5x minus C is 35 equals D is 15. So what are we going to do to solve this equation? What's our first step?
We're going to add 35.
Add 35. Great. So 5x equals 50. And then what? Divide by 5. X equals 10. So we get the same answers we did before, but you can see it's quite a bit less work once we have the formula rearranged to be x equals D plus C over P, to just plug in the numbers and solve. So if we're going to be doing a lot of those different numbers for those, it's much easier if we rearrange that formula. So let's look at some other examples here. Let's say we have a formula like volume equals length times width times height. And I need to solve this for W, for the width. Well, again, just like solving the other equation, I find my equal sign and identify where the W is. It's only in one spot, which makes life a lot easier for us here. So W is just in one spot. We have to get rid of the L and the H. Both of them are multiplying W. So if they're both multiplying W, I can divide by both of them at once, or I can do this. Probably the simpler way to do it is to say L times W times H is L times H times W. So it's LH times W. And then to solve it, I would divide by LH. So when I divide that out, on the right side, it's gone. All that's left is W. On the left side, we have V divided by LH, which is just going to stay as V over LH. Remember, you can treat the division problems and fractions can go back and forth. We can run into ones a little bit more complex, like R equals KL over D squared. If I want to solve this for L, so again, I find my equal sign. Come on. I find my L. L is here. There's only one L in here, so that makes it easier. Now what's been done to L? L has been multiplied by K and then divided by D squared. So to solve it, I'm going to reverse that process. I have to multiply by D squared. You cancel that out. So multiplying by D squared over here. R times D squared is RD squared. All that's left on the right side, the D squared is canceled out, is gone, so all we have left is K times L. Now to get L by itself, it's being multiplied by K, so we divide by K. That cancels it out over there, leaving us with L. So R times D squared divided by K is just RD squared over K. So I've rearranged that formula so it's L equals. I might have P equals current squared times resistance. I might be asked to solve that for I. So this one's going to be a little trickier. Here's my equal sign, and here's I. Now there are two things that have been done to I. I has been squared, and then it was multiplied by R. So to take this apart or to solve it, I would have to reverse it. I would first divide by R, which is canceling that out. So over here, P divided by R is going to be just P over R. What's left on the right side is I squared. So now we have to get rid of the squared. What is the opposite operation to squaring something? Square root. Very good. So the square root is going to cancel out the squared. I have to make sure I square root the other side. So that is the square root of P all over R. Make sure that's all under the square root equals I. So let's go back to that previous problem. Well, let's do one in between here first. Let's say I have something like D equals H over, well, let's do D over A equals H over V. And I want to solve this for H. Well, here's H. The only thing that is keeping H from being alone on that side of the equation is it's being divided by V. So to solve it, I get rid of the V by multiplying by V. So I have D over A times V. Now I could leave it as D over A times V, or I can make that a V over 1, so I can multiply this out. So on top I have D times V is dV. On bottom, A times 1 is just A. So dv over a equals h. The other way I could have looked at this problem is this is a proportion. So I'm solving for h, I would cross multiply and divide. I'd treat h as though it's not there, it's missing. So this is the diagonal where I have both numbers. So d times v is d times v. Then divide by the third number, divide by the a. So h has to be dv divided by a. So now let's look at that same problem. D over a equals h over v. But this time I'm going to ask you to solve for a. Well, a is right here. It's on the bottom of a fraction, which makes it a little bit trickier to solve for. So since it's on the bottom of a fraction, in this case it's in a proportion, so it doesn't matter. I can just go ahead and cross multiply and divide. So I'm going to treat it like it's not there. So here's the diagonal that I have the numbers on. dv again, so it's d times v. And I'm going to divide by the h this time. So a is equal to d times v divided by h. Well, what if we don't have two fractions? What if we don't have a proportion, but we're still asked to solve for a number that's on the bottom of a fraction? For example, let's say we have p over m equals d. We're asked to solve for m. Well, this looks different from the one we just did up here because it's not a proportion. But we can make it a proportion rather quickly by just putting d over 1. So now to solve for m here, we're going to treat m as though it's missing, and we'll cross multiply and divide. P times 1 is just p divided by d. So m is equal to p divided by d. So let's add a level of depth to that. Let's say we have, back to the one we looked at earlier here. Where did I put it? R equals k times L over d squared. And this time I want to solve it for d. Well, since d is on the bottom of a fraction, the easiest way to solve this is to make it a proportion. So I'm going to make it into a proportion like that. So I'm going to treat now the d is right here. So I'm going to treat the d as though it isn't there. And I do have to remember it's not just a d right now, it's a d squared. So I'm going to cross multiply this way. 1 times KL is just KL. Then I have to divide by the R. So divided by R. But remember, that's not d that equals that. That is equal to the d squared. So d squared is equal to k times L over R. What do I have to do to get d by itself here? Square root. Very good. So square rooting d squared, the square root and the squared cancel out. That'll just give me d. I have to square, the left side as well. So I make sure that when I write that, I put the square root over the whole thing. It's the square root of k times L divided by R is equal to d. Oh, let's see. Let's look at one like this. So in this one, let's solve for f. So looking at this, we see parentheses. And whenever we see parentheses, it should tell us we have to do something there first. So we look at the parentheses here. Is there anything we can do inside that parentheses? Can we combine f minus m? No, we cannot. So we're going to have to multiply by the b. So b times f is bf. B times a negative m is negative bm. Now we're still solving for f. So here's f right here. We have to get it by itself. To get f by itself, we have to look at what's been done to it. F has been multiplied by b, and then bm has been subtracted from it. So I would add bm. So p plus bm is just p plus bm equals bf. And now the final step in solving for f, I have to get rid of the b. The b is multiplying it, so to get rid of it, I divide by b. Very good. So that divides out there. So all I have left on the right side is f. P plus bm, I could write that in one of two ways. I could leave it exactly like this as p plus bm over b, or I could divide it out. P divided by b is p over b. Bm divided by b is just m. So I could write it like that as well. There's an alternative way I could solve this by circumventing my order of operations just a little bit. When the only thing on one side of the equation is a parentheses that's being multiplied by a number like this is, if there was like plus something else over here, I wouldn't be able to do this. But when the only thing on one side of the equation is this distribution here, a parentheses times a number, then rather than distributing that number, the b, I could just go ahead and divide by it. I could divide by b here. Cancel it out. I have to divide by b on the other side. So p divided by b is p over b. That equals f minus m. Then to solve for f, I have to add m. So p over b plus m is p over b plus m. So f is equal to p over b plus m. So you can see here, that made this a little bit shorter and a lot easier to solve. We can do that with our numerical equations as well, but again, it only works when we have just that distribution on one side. Like if we have 6 times 3x minus 2 is 42. Rather than distributing the 6 here, I could go ahead and divide the 6. If I divide by 6 on both sides, what I'm left with over here is the parentheses, the 3x minus 2. There's nothing else over there, so I don't need the parentheses anymore. And on the right side, I can do 42 divided by 6 is 7. And then we solve it by doing what's our first step? Adding 2. So 3x equals 9. And finally, divide by 3. So x equals 3. Okay, I think you guys have had enough for the day. I will warn you, on Friday there will be a quiz on this stuff. So be ready for that. In your big book, on page 392, we'll just have you do up through 393. We'll have you look at 1 through 27, the odd. So that is rearranging these formulas, rearranging the letters so that it is a specific letter equals the rest of the formula. I'll let you guys have your last 10 minutes to get started on that if you want.